approximate method through which we can get a solution. The solution may not be exact, that will be your approximate solution. Apart from weighted residual method, we also have variational approach through which we can get an approximate solution. So here we will discuss weighted residual method. So here you just see we are talking about weighted residual. Okay, so there will be some weight function, and there will be residue. So here we learn how basically weight function is operating on the residue and how we are getting the solution. Now, before going to that method, any method of the weighted residual method, let us understand what is basically residue. Before going to the residue, we should know what is our solution. So we know, if for example, if we know that L phi, okay, if you know the value of L phi, okay, value of L phi is equal to minus F, then we can say that basically phi is our exact solution. Okay, that is our actual solution of our differential equations, and there will not be any error. Okay, now instead of phi, okay, if you use psi, if you use any other function psi, then that value will not be minus F. That value will not be minus F. Okay, so that will be any other value than the minus F. So what we can say, then L in L psi plus F will not be 0 now. There will be some error, will not be 0 now. There will be some error, and that error basically we are saying residue. So here this is our residue. Okay. Now what are the weight functions? Now what weighted residual method is saying? Weighted residual method is saying that you take a weight function and multiply with that residue and try to make the error 0 in the whole domain. Okay. So here in the you are making the 0, you are making the residue 0 in the whole domain through a weight functions. Okay. So basically we are making the error 0 in an average sense. Okay, we are making the error 0 in an average sense of our. Now, if we put the equation here and if we do the integrations, we can make it 0. Okay, now here in the weighted residual method, we have to follow some steps. So follow some steps in the sense we will understand how basically we can work on that weighted residual method. So in that weighted residual method, what we have to do? We have to assume a trial function. Here we are assuming psi. Some cases you will observe that we are assuming phi as a trial functions, but here just see we are assuming a trial function or approximate solution. One more thing you have to remember, that approximate solution need to satisfy the boundary condition of that actual problem. Okay, for example, if you have a cantilever beam, then actual solution also satisfying actual problem, actual solution you are satisfying that here displacement will be 0 and rotation will be 0 if you consider cantilever beam. Okay, here displacement will be 0 and your rotation also be 0 in the end, fixed end. So your approximate solution or the trial solution also need to satisfy the same boundary conditions. Okay, so once we assume a solution, trial solution or approximate solution, then what we will do, we will put the solution in the differential equation. You will put the solution into that our original equation. Okay, now if you put the equations, then we will get the error. So basically we will get that error, that is basically calling as a residue. Okay, now this residue we need to make 0 in a average sense over the domain. So what we will do, we will take the help of a weight function and multiply the weight with that residue, and we will integrate over the whole domain, and we will make the residue 0 over the domain in an average sense. This is basically weighted residual method. Okay, now in the weighted residual method we have various methods. Okay, we have various methods, and here we have various methods. So in various methods we have very popular method, that 4 popular method we have, that is your Galerkin method, square method, point collocation method, and subdomain method, that also called subdomain collocation method. So these all 4 methods basically differ on the basis of how basically we are assuming the weight function. How we assume the weight function, depending on that we have 4 methods. Okay, so here